You might think a black hole is black. Wrong. It has no color whatsoever. You might think a black hole is, well, a hole. Wrong again. It is the densest entity in the entire universe. You might think that if you fell into a black hole, you'd be crushed flat. Dead wrong. Instead, you would be stretched out like a noodle, pulled apart while still alive, into a single slender filament. This process has a specific name: spaghettification. Even more terrifying is that, at the very moment you meet your gruesome end, to an outside observer, you would still appear to be alive. This is because a black hole distorts time itself. While you might experience just 1 second of screaming agony inside, 10,000 years would have already passed on the outside. And just when you thought black holes were safely distant, scientists tell us this: right at the center of our own Milky Way galaxy, one lies in wait, a supermassive black hole with a mass 4 million times that of our sun. It is currently devouring everything that strays too close. The only good news is that for now it cannot reach Earth. The bad news is this: hidden throughout the universe, there may be billions of other black holes that remain completely invisible to us. Which begs the question, if one day a black hole were to suddenly appear within our solar system, how much time would humanity have left? The answer is, we might not even have the chance to react. In April 2025, scientists confirmed the existence of, for the very first time, a solitary rogue black hole. With a mass more than 7 times that of our sun, it is hurtling through the cosmos at a staggering speed of 51 kilometers per second. It has no stars. It has no companions. Like an invisible assassin, it has been lurking in the darkness for billions of years. Even more frightening is the possibility that our Milky Way galaxy may harbor hundreds of millions of these rogue black holes. They emit no light and generate no heat. You can never know if, in the very next second, one might suddenly materialize right in Earth's vicinity. But that isn't even the craziest part. Scientists have discovered that approximately 10 million years ago, right at the center of our Milky Way galaxy, a cosmic murder of epic proportions took place. An intermediate mass black hole, 5,000 times the mass of the sun, was the one being welcomed. A supermassive black hole, 4 million times the mass of the sun, swallowed it whole in a single gulp. The energy unleashed by this collision flung the surrounding stars out into the depths of the universe at speeds exceeding 1,000 kilometers per second, condemning them to an eternal escape. Both the perpetrator and the victim were black holes. This was a cosmic-scale act of black-on-black violence. Speaking of eating, do you have any idea just how voracious a black hole? There exists a monstrous black hole in the universe known as TON 618. Its mass is 66 billion times that of the sun. What does that even mean? If you added up the mass of every single star in the Milky Way galaxy, it would amount to only 64 billion times the sun's mass. A single black hole, therefore, weighs more than the entire Milky Way. Its event horizon, the point of no return, spans a diameter of 390 billion kilometers. It could comfortably contain 1,600 solar systems. If you were to pilot a spaceship traveling at the speed of light from one edge of it to the other, the journey would take a full 6 days. But what baffles scientists most is this: TON 618 simply shouldn't exist. According to the laws of physics, black holes are subject to the Eddington limit, which restricts the rate at which they can consume matter. Yet, TON 618 had already grown to such colossal proportions when the universe itself was only 3 billion years old. How did it manage that? No one knows. Recent research has revealed that some black holes are capable of feeding voraciously at rates exceeding theoretical limits by a factor of 40. This implies that our current understanding of black holes may still be stuck at a kindergarten level. And now, for something even stranger. The temperature at the edge of a black hole can reach 1 billion degrees, 180,000 times hotter than the surface of the sun. Yet, venture just a few millimeters inward, and you would find the coldest place in the universe, approaching absolute zero. Physicists refer to this extreme contrast as the firewall paradox. If you were to be thrown inside, you would simultaneously witness 2 distinct fates. In one version, you are incinerated, turned to ash. Another was frozen solid, and remarkably, both are true. This is where quantum mechanics and the theory of relativity clash head-on within the realm of a black hole. Neither can reconcile with the other. In 2019, humanity captured the very first image of a black hole. It was the supermassive black hole at the center of the M87 galaxy, a behemoth with a mass 6.5 billion times that of our Sun. In September 2025, scientists released its latest images, revealing a startling phenomenon. The magnetic field surrounding the black hole had completely flipped direction within just 4 years. This demonstrates that the environment surrounding a black hole is a region of extreme chaos, a turbulent, ceaselessly churning maelstrom. Spewing from the M87 black hole, a jet stretching 5,000 light-years into space is performing a cosmic waltz with an 11-year rhythm, oscillating back and forth once every 11 years. This marks the first time humanity has ever witnessed how a black hole twists matter into a spiraling helix before blasting it out into the depths of the universe at nearly the speed of light. At this point, you might ask, will black holes exist forever? The answer is no. As early as 1974, Stephen Hawking predicted that black holes would slowly evaporate through quantum effects. Although the process is incredibly drawn out, it would take 10 to the power of 67 years for a black hole with the mass of our Sun to completely evaporate. In the very final moments of its disappearance, it will unleash a cataclysmic explosion. Yet before that happens, an even greater catastrophe may strike first. 4.5 billion years from now, the Milky Way galaxy will collide, or rather, merge, with the Andromeda galaxy. The supermassive black holes at the centers of both galaxies will begin to orbit one another, eventually merging to form an even more colossal monster. This collision will unleash powerful gravitational waves that ripple outward, propagating across the entire universe. And our descendants, should they still exist, will witness this entire spectacle with their own eyes. As of the end of 2024, humanity has already detected over 200 gravitational wave events each time. Gravitational waves. They are the final messages left to us by black holes. In 2019, scientists detected the most massive black hole collision ever recorded. 2 black holes, weighing 85 and 66 times the mass of our Sun, respectively, collided, merging to form a new black hole with a mass 142 times that of the Sun. The missing 9 solar masses were entirely converted into gravitational wave energy, an energy output equivalent to the total energy released by every star in the entire observable universe all at once. This collision occurred 17 billion light-years away. The gravitational waves traversed the entire cosmos before finally reaching Earth. What lies at the center of a black hole? There exists a singularity, a starting point, with zero volume, infinite density, and infinite gravitational force. At this point, Einstein's theory of relativity breaks down. Quantum mechanics collapses, and all known laws of physics cease to apply. Some scientists speculate that it may serve as a gateway to another universe. Others suggest that time itself ceases to exist there, that the past, the present, and the future are all compressed together. But truth be told, no one really knows, for nothing that has ever entered has ever returned. The black hole closest to us lies in the direction of the constellation Ophiuchus, more than 1,500 light-years away. With our current technology, a journey there would take over 20 million years. Our solar system happens to reside within the Milky Way's habitable zone, a region where we are neither torn apart by black holes nor situated so far out that we lack the elements necessary for life. It is a fortunate gift bestowed upon us by the universe. When we gaze into a black hole, we are witnessing not merely the limits of the cosmos, but a breach in the very boundaries of human understanding. From the quantum realm to the gravitational domain, from the nature of time to the conservation of information, all the ultimate questions of physics find their lessons within the study of black holes. And this journey of exploration has only just begun.